Hey YouTube, thanks for tuning in. Today we're going to be continuing on with where we left off. So we finished step 2 and 3, and now all that we need to do is import into Trimble Business Center. And so go into the densification inside of your photogrammetry job, and then I've already imported the first 10, and we'll just go ahead and handle 10 at a time and then verify that they're coming in correctly. So here in Trimble Business Center, I'm going to go ahead and do a grid scaled and a specified coordinate system. Since we processed at ellipsoid, I'm not going to assign an ellipsoid, and then let it chew. So for a large scale project like this, sometimes it's nice to have split surfaces. Depending on what your team's hardware is, and in this case I'm just going to be doing it all as one surface, but you very well might want to have or to split this up into multiple surfaces. Like I said, I'm just going to be using one surface, but you might look into doing multiple. Okay, so now that everything is loaded just fine, then we can go over and get a 3D view. And let's just inspect our data just very quickly. I'm not going to go into too much depth here. Just turn on my control and my targets. Looks like some paint striping there. Looks like we have a slight vertical offset here, but we'll figure that out here shortly when we get into the actual data processing. This must have been a cap that was above ground. Yep, it was. Here's the target. Okay, so let's get classifying this data. So zoom out. We'll switch back to our planning tab. We'll select our point cloud. Go into our point clouds, and then we'll classify. Now in my classifications, I'm just going to classify the ground out. While we wait for the point cloud classification, let's go ahead and prepare our raster image. I have all of my tiles loaded up, and this data set looks pretty good. It's a pretty sharp data set. And if you want to verify that your points came in correctly, then you can go ahead and set the right fields. In this case, point northing easting, so I'm going to have to set these accordingly, and then make sure to specify your coordinate system that your file is in. I'm not going to do anything with the Z, because I can just care about the X. Let's go ahead and collapse all of our images. And then you're going to want to make sure that your actual coordinate system is still correct. So let's just make sure. Okay, so now I just drug my points up to the top, and let's verify that everything is in the right spot. So with no input whatsoever on my end, then the data looks pretty decent and how it's matching, and so I've allowed it to basically match everything on its own and just accepted the positions. So I'll just go ahead and go to a couple more. It looks pretty good. The match is a little bit off on some of the geolocation here, but in this case, then this data set is not for 1-inch precision layout, or at least it should not be, and I'm going to have to subsample, so let's go ahead and start our subsample. So in this case, I'm going to be retiling these images. And I'm going to be setting this to a pretty decent size, so probably want around 10,000 for your size here. So if you check out the help on the tile size here, you'll notice that it's in pixels, so we're going to have to do a little bit of math. So if we check out our image here, then we'll be able to see what size resolution this is. So we're at 500ths resolution on the GSD, and so we're going to need to figure out what our pixels are going to be. So it looks like in our case we're going to need 105,000 to get a mile tiling size. So make them the same. And then we're going to output into our coordinate system, and we're going to be using a JPEG compression. Now this is for Civil 3D prep, and this is going to make the size of these images way more manageable. So let's set our output directory. And then let's click run. The other option that you have is to set up a new print layout. So let's go through that. So this is probably the easier way for people to go. So if you want a 5280 split, then you could do a ortho at a 5280 split. So let's just name our layout, and then go in, set a custom page size here. We'll do it in inches, and we'll do 52.8, which is a large paper size, and that's okay. It just makes the math a lot easier since we already had done the math. Now if we wanted to hit our target resolution at 500ths of a foot, then at 52.8, which is 5280, at our pixels, which we found out was 105,600, then we would divide by 52.8 inches, and that would get us our pixels per inch, which is 2,000, which is directly going to drive our DPI. And so 2,000 is pretty large, so we're probably going to need to do at a ½ mile interval for our export. In order to make this more predictable, let's go over and create a grid. We'll do a rectangle, and then the extent here. You can add extent, or you can draw one in. Go ahead and draw in our extent here. Now all that's left is to set your horizontal spacing and then create the temporary file. Now we have what's called an option to do our map atlas, so we'll just go ahead and toggle it off for now, and we'll head back to our map layout. So in this case, we're going to have to add a map, draw it in here, resize to fit our page, and then we'll go ahead and turn on Atlas, and we'll set our Atlas to the ID, and then we're going to sort by our row index. Okay, so now that all that's left is to set our preview to on, and then let it regenerate. So next, we'll go ahead and set up our page so we can do our item properties, and then we are going to control by our atlas, and we're going to go ahead and set this to 0 margin. Now that we have our margin set, then we can go ahead and specify, we can go back to our atlas, and let's just make sure that everything is set properly. And now once you're happy, then we can export Atlas as images. We'll go ahead and put this same place. And in this case, if we do 300 dpi, it's going to be roughly 2 inches on the ground. And the way that you figure that out is your page inches divided by your distance, or your target distance divided by your inches. And then, so in this case, it's easier to figure out what your DPI is. So if you take 2640 divided by 300, you'll have roughly 2 inches. So I want to cut that in half, so I'm going to be doing a 600 DPI export, and I'm going to also generate a world file. And so let's go ahead and save. Now that our TBC, well, that imagery is outputting, then we can go back to our TBC, which is done classifying, and let's go ahead and output this file here. So this is going to be just go ahead and save this out as our LAS here. So the last step is, before you can export, is to set your local site. And so I've brought mine to ground at a known control location. And so now I can go ahead and export this out. Make sure that in this time you're going to select your ground scaling, since we have assigned our ground scale. Now I know not everyone is going to want to store this much data, but I also output the full point cloud. So I do the ground, and then I also do the full point cloud. So then there's no question when I go into my raw sensor data, when I'm trying to do more processing from here, which point cloud to grab. I never have to worry about grabbing a point cloud that is still ellipsoid height. I can make sure that these are in geoid 18,
and our local site scale factor.